Hello, everyone. Very nice to see all of you. I hope you're well. I hope you're not too hot in any place of the world that you are. We are very hot here in Paris, and we are looking forward to receiving the Olympics game. We are seeing quite a lot of people joining at the same time, so we are going to wait a little bit. Philippe, Martin, how are you?
Yeah, very good. As you said, a bit
Thanks.
hot.
Bonjour Elmedi, hello Roldan. Very cool to see you. We are expecting quite a bit of friendly faces and new faces as well. So for those who haven't been into some of our webinars, this is a very open conversation, open webinar. So please do not hesitate to ask any questions or any topics that you want Philippe or Martin to discuss today. Obviously, 5G security is a wide area, and very much curious to hear your questions. Bonjour Algis, hello Thomas, William.
And yeah, remember, there's no bad or stupid question. And sometimes the most interesting and most difficult ones are the simplest ones. So we've got great feedback from previous webinars and a good upcoming, or how to say, downstream question. So this is actually the start of a conversation sometime, which is quite interesting and valuable.
We are going to wait a minute or two before we start. This is not the first time we have discussed about 5G security, and this will not be the last time, for sure, when we see the number of people that are here today. So thank you for spending your precious time, and hopefully this is going to be helpful for everyone here, and for the one that is going to hear us with replay, because what we are seeing is there is a lot of you are also going back to the content and re-looking at it afterwards. And for anyone who is asking the question, this session is recorded. You will be able to retrieve all the content afterwards, and any colleague, friends, whoever that is curious about 5G security can access it afterwards, not even though they haven't been registered to this session today. It's really open for everyone. So Philippe, Martin, I guess we can start. And people will get on board quickly afterwards. The topic, navigating 5G security realities. For those here who don't know really much about P1 security, we are one of the foremost experts in mobile network security. What we do is offensive security and telecom security software products towards telecom protocols. And we've been working very heavily on 5G for the last few years. This is a very ongoing topic and topic on which we deliver several missions at the same time all year long. And what we are trying to share, and what Philippe and Martin, from their experts' point of view, will try to share today, is what they are seeing on the field. So hopefully you are from MNOs, consulting companies, regulators. We are seeing agencies. There is a lot of people here who are here to are curious about what we see, because we have a view that is kind of a benchmark over the 5 continents. So hopefully it's going to be helpful for you. I leave the floor to the people who actually know something about 5G security, which is Martin and Philippe. Thank you, Philippe, and I guess the first words for Philippe, the CEO and founder of P1.
Yes, hi, and thank you very much. So yes, as Pierre was saying, we've been doing now pen tests and audits and delivering software for security for more than 15 years. So it's been a while, and basically the transformation of the telco and mobile network security through the years means that we accumulated, of course, a lot of legacy, but at the same time we have bright new security principles and new attack surface to defend. So the goal of this presentation is to present what we see, an extract of what we see of all the engagement and all the feedback and all the insight we get, not only on the technology, but also on the market. So very quickly here, I'm going to, if I manage to switch the slide, correct. So we are going to have a look into what's currently deployed as 5G networks, and then dig deep down in some of the attack surfaces, what we see as new perimeters or perimeters that are very likely to be vulnerable. And then we'll deep dive into some example of vulnerabilities on some of the vendors and some of the networks that we've looked at. And then we'll end with basically an overview, a 360 overview of what we see as a 5G security market. So here, what we can say is that first, there's many different 5G security environments. And the two biggest differentiation are between 5G non-standalone and 5G standalone technology. So now we have an extreme majority of networks around the world who have 5G non-standalone, that is 4G core networks that supporting both 4G antennas and 5G, basically new antennas that are slave to the 4G core network. In this way, basically, that's a bit of a fake 5G or marketing 5G, because you just have a new radio and not much of the new features that we see in the 3GPP standard releases. And that's what we get when we get a 5G core, is that this 5G core is also called standalone technology, where we have one dedicated core that serves the G node Bs, so the 5G base stations. And in that case, we see a lot more of complexity on attack surface. That's the real 5G. And that comes with some flexibility in terms of security, but at the same time, a real big increase into basically the attack surface and the places where an attacker could attack. So we see also that lots of MNO are struggling to deploy standalone architecture on 5G core, but some are already production and are already delivered to the general public. Now, what is very interesting to see is that we see many different kind of 5G networks from these public 5G networks from operators down to private 5G networks. First, they are being used for first responders, Ministry of Interior, such kind of very dedicated application. Then for general enterprise, enterprise 5G networks. And few of them are actually rolling out edge computing too. So we see that there's a big mix, a lot of differences between the different kind of 5G networks. Now, these 5G networks, generally, when we talk about what they bring first, definitely speed, that's for sure. But there are quite a few items which are make it very varied. For example, when we talk about some of the security benefits, for example, there's a much better concealment of the subscriber identities with using things such as subscriber concealed identities or SUSHI, and subscriber permanent identities. And also this has a benefit not only on the radio side, but also and a lot in the interconnect. Now, when we talk about interconnect, that's mostly roaming. And for now, 5G core roaming is really being just tested. It's really something that is upcoming. But some operators were surprisingly saying that it was going to come quite quickly in the next year or next 2 years. So we were quite surprised of the willingness of adoption of these kind of technologies. Now, what we see also is, in terms of 5G core, is a huge uptake of containerized cloud-native core technology. That means that 4G were heavily resting on virtualization, but actually the 5G seems to have moved away a bit from virtualization, even though some retain it for ease of managing computing resources. And then we are seeing the vast majority of 5G core which are using containers and Kubernetes. Interestingly, Kubernetes is also being pushed towards the edge to manage the workload on the edge computing. So that's something quite interesting. And lastly, we see some virtualization being used by some operators who are actually rolling out their 5G core on public cloud. And we're very astonished to see that this was actually taking place. Our assumption was that it would not really happen and would have a lot of barrier to that, especially from the regulators. And actually, some are testing it. So we are going to see if it really goes live or not. Finally, we've seen a lot of people saying they do Open RAN, but in terms of deployment, much fewer who are really using Open RAN for disaggregated radio access network. So all in all, what we see is really that we have a very diversified picture, much more diversified picture in terms of 5G networks that we audit, deploy security into, etc., compared to even 4G networks. And if we look at what it means in terms of security overview, when we compare a typical, deployment from 4G to 5G, we see that some complexity was added in order to cope with many of the features that's supposed to come with 5G core networks. And if we look at the 4G core, the 5G one is actually being so complicated that there were some changes into it in order to make it more manageable. For example, if we take this reference implementation and reference representation, it's taken actually from an Open 5G core, which is an open source project. We see that this was a theoretical deployment. And in practice, many deployments don't go for these peer-to-peer application level APIs of the network, but go through a centralized service control proxy, which helps deploy with less complexity this network and these HTTP2-based interfaces. We see also that a lot of attack surfaces now coming directly into the network, because since it's APIs, then enterprise services tend to expose and use a lot of these APIs. And people were, such as enterprise customer, quite outside of the core network, now have more and more exposure to endpoints which are inside the core network. It's also the case for non-3GPP accesses, which is a big word for Wi-Fi access into the network, where we see that there are new attack surfaces to deal with this kind of new access methods or access technologies. Also, one thing that we've seen so far is that the difference between what should be in a network and what actually is in a network is very interesting. When we see these reference representation, they really don't depict what we really see. So we had to actually build our own representation of what we see and with which probability we see these network elements into a 5G core network. So this kind of problem, I would call it a problem. It is really a problem because people tend to think about 5G core network when designing the security architecture in ways which is actually different from the reality of the network and what will be the reality of the network. So another pressure point that we've seen on CISOs and security directors within the telco and mobile network is that the regulators are looking more and more into these 5G technologies. So the network that had the most pressure in terms of security is definitely the 5G network. And now regulators are getting into this, setting up labs, setting up test beds, sometime before even that the operator was able to achieve their own 5G test bed. And some governments are super aggressive in pushing the regulator to really have deep knowledge about what actually is into the network and to model the attack surface, the security parameters of the 5G core networks. So here, if you look at it, of course, we have the traditional legacy attack surfaces or perimeter, which is typically the radio interface from the to the 5G radio access network. And then we have, of course, the legacy signaling from SS7, SMS routing, diameter, etc. We have also the data network, which is, as always, now it's not interconnected with GGSN and PDN gateway, but with UPF that replaces these new network nodes. But what we see is that new kind of security perimeter are being are exposing the core network, and specifically the network exposure function, which is designed to that, but also application function, which are just application servers for example, enabling the enterprise customer to control access to their slices, to manage fleets and IoT applications, etc., etc. And we see, in the end, the internal core network, of course, starting to be interconnected and tested for roaming. So this is getting interconnected with the SEP, which is basically a proxy that will block or allow roaming messages, signaling messages. And then in the end, the SCP and NRF, which are central point for this 5G core network. What's very interesting is that depending on which vendor we see, we actually have a complete different deployment model coming from the vendor, and sometimes they have to enable interoperability to actually start using HTTP2. So this is very interesting to see which kind of choices and then what kind of security impacts are downstream from these decisions from the vendors. Also, we see some kind of network in a box where actually the whole core network exists into a central servers, and this is especially the case for 5G private network deployment. Now, when we see this kind of deployment, we see already a complexity, and when we dig into one specific network function, we actually see that these network function combine usually 2G, 3G, 4G, and 5G capabilities into a single node, and as such have the corresponding complexity and corresponding attack surface. So that means that vendors also do have a difficult job to test all the kind of configuration, messages, and resulting behavior of the network function. And here, for example, we look into a Nokia cloud, basically, how to say, AMF and SGSN and MME at the same time. So it's basically a cloud native enabled. So it's using cloud native technology from CNCF, Cloud Native Computing Foundations, to support some very legacy code and some brand new code. So very legacy code comes from 2G, 3G, diameter, 4G, 4G diameter, SS7 compatibility. And then we see brand new developments which are resting directly onto CNCF and Kubernetes technologies. This coexistence of very legacy code and a very new code makes it a very varied attack surface. For example, we see some network functions that don't respect the rule of two. So rule of two in security is a new concept that says, if you listen to the network, you cannot be developed into a language that is not memory safe. And typically, the reason for that is buffer overflow, off by one, use after free, these kind of vulnerabilities that are kind of difficult to find. And even if we see, for example, some of these network functions, which are coming after security audits, after SCAS and network element security assurance schemes scans, we still find vulnerabilities in there. And we had, for example, recently we closed an audit where we had a complete core, which was basically completely scanned for vulnerabilities according to the SCAS profile. And yet, I think we found, I don't remember exactly the name, but it was in tens of vulnerabilities. So we had at least, if I remember correctly, something like 20 or 30 vulnerabilities into something that was scanned for vulnerabilities. So we see here that there's still a tough job, and some of these network functions are failing to mutually exclude these memory unsafe languages and listening to the network. And here, security principles are still not respected into many of the target equipment that we audit. So that means when we have such complexity and we have such a wide network to cover, we need to have some kind of methodology in order to do this coverage and some automation, some scanners, some passive monitoring and detection systems in order to verify that the security constraints that make it a good network are actually followed. So let me transfer now to Martin, who is going to talk a bit more about this.
Okay, thanks, Philippe. So let's move to more security audit approach, and basically I will try to outline the strategies which can be taken during the audits, and later on I will also we will highlight some examples from our audit experience of 5G SA network. So basically on this slide it can be seen how we can move and change our approach from more black box approach, which is seen on the left, and make the transition to the more white box approach. It basically depends on the prerequisites which are provided to us during the audit. So we can really approach it just with some IP connectivity. So this is the scenario on the left. And we can start with performing actions like really approaching the black box and doing like network discovery, port scanning, discovery of the services, and maybe approach it directly from the IT or the management network, and then trying to enumerate the vulnerabilities, try to gain access, and basically doing more common pen test exploitation. Then if we succeed with gaining access to certain network function of the 5G, we can then start to escalate the privileges. So we are here in the second step, access to the system. Then maybe check the file system, what kind of files are present, readable to, let's say, non-privileged user, maybe eventually check the files, binaries, and then maybe even run some vulnerability scan locally on the system. And of course, even try to detect if there is Kubernetes running or if we are inside some container and so on. If we manage to escalate the privileges, we can move, let's say, to the step number 3, like having root access to the system, and this enables us even to perform more actions. So basically, common approaches, we can capture the traffic which is processed by the system and then analyze the traffic. So this can reveal, for example, some insecure protocols seen and process, or maybe detect some unencrypted passwords, credentials, or sensitive content within the traffic. We can additionally perform by system audit, like even access different binaries on the system, check nearly the whole file system, and even maybe descend into individual containers, and we have better privileges. And then during the audit, if we are or if it was given to us access to different networks, maybe we can access it directly from this, let's say, rooted network element, or if basically the operator or the vendor provided us these different perspectives, then we can maybe try to scan it from different perimeters to understand what is the exposure from the like access segment or from the signaling networks, maybe check if there are some segmentation issues or wrongly configured segmentation and so on. Then just maybe to move to the audit preconfiguration, the second from the right. If we are able and if we are configured towards the signaling network, maybe simulating other roaming partner, or maybe simulating like G node B in the 5G, then we can do other and additional actions. So we can really simulate how the 5G network is protected from the interconnections, and if some roaming partner is performing some, let's say, illegal actions. So maybe he can be sending some illegal signaling or even malformed signaling, or maybe try to geolocate the 5G subscribers. And then the last point, more accesses and information we are able to get, maybe even check the vendor documentation, maybe architecture documents. It can be used to better understand the overall environment. And then we are really moving to this white box approach to try to achieve the best results. What I mentioned regarding these audit perspectives. So this is quite important to understand during the security assessment, because it can basically help us to design the different security tests what we are going to do. So we can really approach the 5G technology like from the management perspective. So this is from the operator network and from these administrative accesses, and basically to let's say unbox the 5G network elements. But additionally, we can also try to scan the 5G networks from different perimeters. So this is basically the drawing what we have already seen, what Philip presented. But now let's focus where we can maybe connect our audit appliance and which perimeters we can try to test and detect for the vulnerabilities. So in this drawing, we see the 5G service-based interfaces basically connected everything to the single bus, and we see these different 5G network functions. In the bottom, we see the RAN, the access segments, which is being connected to the 5G network. So we see 5G new RAN. And then on the right, in the center, we see also this roaming exposure and the connection to the SAP. So basically, this diagram illustrates what are the most risky segments and which are the most exposed one. So we see really the access segment. We see also the interconnection, because we could not fully trust other operators. We see also the data network and the UPF exposure. We have the legacy stuff like the SS7 diameter, which can also possess some threat. And then in the 5G, on the top right, we see these verticals. So the 5G could open the API functionality through the network exposure function to the third parties, and this can be the other attack surface. And in the middle, we can imagine that also we can have, let's say, compromised network function, which is inside the 5G SBI, and which can also possess the risk. So on this diagram, you can imagine that every perspective could be interesting. And in this scenario, you need to connect your, let's say, auditor virtual machine and to simulate the attacker coming from these perspectives. Now, what we have seen during our assessment. So basically, we have very often seen that Linux is heavily used in most of the systems by various vendors. Data plane is very often handled by dedicated hardware, so that there could be really the dedicated boards and the cards processing the user plane. In some rare cases, we've seen also the SCTP signaling stack processed by the in the operating system, but very often the user plane is offloaded to the dedicated hardware. Then regarding the 5G network functions, so far we see really few slicing configuration. So very often it is just the default slice, and the operators do not yet very often use really the slicing functionality. But they are interested even to learn more and maybe even to discover the various or to test the security of the 5G slicing. And then regarding the inter-NF communication, so very often we see the mutual TLS configured. So this is between the communication between the network function and other network function, or NRF. However, very often it is like self-signed certificates, and even the authorization is not really fine-grained. What does it mean? It means something like, if you have the certificate, maybe you can use the 5G API to trigger different methods through the API, which does not belong to your network function. So scenarios like compromised network function maybe can execute different APIs. Now, regarding some examples of the vulnerabilities, so we can really move maybe from the physical level to the infrastructure level and then to the other levels. So regarding the physical level, these some examples could be maybe insecure physical security. Maybe some Gnode B's sites are not well protected and could be compromised. And then, for example, the front haul to backhaul communication, which could be intercepted or even could be leaking some information, or the attacker could maybe inject some communication there. Then we can have maybe some data networks links and maybe even some communication between some data centers of the mobile network which are not well protected. Now, if we move to the infrastructure level, we can see that there are different network functions. Some are virtualized, some are containerized, and we have seen also like insecure container and Docker configuration. What does it mean? Sometimes there are too much privileges given to certain pod or basically Docker. Sometimes it is possible even to escape from the container or the Docker because of the insecurities there. Then we have seen also like missing network segmentation or micro-segmentation. So this is the scenario if you imagine that some network function got compromised, but if the attacker can now perform some lateral movement, access directly the adjacent network function through the management plane, this is not something what is really wished and correct. We have seen many times hard-coded secrets, passwords, even private keys within the binaries or the scripts or inside the files on the file system. Local privilege escalation is sometimes quite easy to perform because of some insecurities in the system. And then the case of the pivoting. So compromised network function could lead to the pivoting to different systems, maybe even to some really highly critical or sensitive system like lawful interception, or maybe to compromise the element management system or some other OSS BSS systems of the mobile operator. Now, some other examples from different areas. So on the signaling level, if you imagine that the signaling is still exposed in the 5G network because we have the roaming, which can be eventually opened, and we have also the radio and the access network, like maybe Gnode B could be compromised, but also directly from the access segment, basically the phone is communicating through basically NAS, for example, with the AMF. So also there is some decoding and processing of the AMF and handling directly the inputs from the user equipment. So the examples could be even to crash maybe some network function because of malformed signaling messages, or eventually if there is unsafe, let's say, programming language use, even to do some maybe remote code execution. If there is maybe Java or Golang, it is more unlikely to do some remote code execution, but still some availability issues could be done. Regarding the other issues, this can be like bypass of access control. So it is like if there is not done application level, let's say, filtering of these signaling messages, you can imagine that one roaming operator could maybe abuse the API of the 5G and maybe geolocate the subscribers. So we will again repeat the same story like in SS7 and Diameter, that the signaling networks are still not yet fully secure, and some, again, signaling firewalling is still required in the 5G. And then we can have like some subscriber facing issues. So there could be maybe some insecurities configured, maybe that the AMF is accepting insecure NAS connections without some integrity protection, or the operator is not too frequently performing the authentication, or the TIMC is predictable. Possibly that even the network functions were not tested towards the 3GPP SCAS security profiles. So all this could increment and increase the privacy risk of the subscribers. And then, of course, we have some other MISC systems in the 5G, like power management, maybe some systems which are integrated with the 5G, even like the OSS, BSS systems of the operator, which can even increase the risk. And now let's see certain examples from our assessments, what we discovered on the 5G network. We have some examples from these different areas. So this one belongs more to the infrastructure level. On the left, we see that the clear text OEM protocol and communication has been detected between the eNode B, gNode B, and the network management system. So the attacker can basically compromise the communication, sniff the communication, maybe retrieve some sensitive data, maybe some plain text passwords. So this was seen on the in the real deployment. In the middle, there is other vulnerability. This is that the hard-coded OEM credentials has been discovered in the eNode B, gNode B, and then the attacker can directly exploit this and gain access to the eNode B, gNode B of the given vendor. And on the right, we see multiple stack overflows in the gNode B OEM service. So it was possible to exploit the SOAP OEM binary of the given vendor, and even to perform some stack overflows and control directly the equipment. This is important to mention that even if the operator change the credentials, apply the hardening policy of the node, still basically the node is vulnerable to this kind of attacks. Next example, these are the vulnerabilities for the non-standalone deployments. So on the left, we see the example that MME is vulnerable to malform S1 AP message. So MME is basically could be crashed and the availability could be impacted. And the attack scenario is if somebody compromised the eNode B, the attacker can then, for example, to craft some malform S1 AP packet or the message, and by this directly target the MME and to crash the given network element. The consequence is basically the white outage of the 4G network in the given area, which was served by the MME. In the middle, we see example that the DRA or HSS could be vulnerable to malform messages. And this is again the diameter protocol stack could lead and even crash these network elements. Why this is dangerous? Now the attack scenario is slightly different. Now maybe the roaming partner or some compromised network element of some roaming partner could be used to deliver this kind of malform message, and then in this way even remotely perform the crash of the target network operator. And on the right, we see other issue with the 5G non-standalone. So within the GSMA, we try to contribute to these recommendations, and the recommendations are tracked in the FS19 and FS20 documents, which covers the basically application layer filtering or firewalling for the diameter and GTPC protocol. So these two protocols are required to be opened for the roaming, to enable basically the roaming for the 4G networks. And then there is required to perform a kind of application level filtering to protect the network against some illegal traffic. Now let's move to the 5G standalone vulnerabilities example. So on the left, we have some issue with containerized network function or virtualized network function. And the issue could be that if somebody compromised the network function, he can possibly escape the container and maybe even get to the host VM and basically escape this kind of sandboxing, and then eventually compromise the whole infrastructure. So we have detected certain vulnerabilities which really clearly demonstrated this. In the middle, we see also example from the real product, what we assessed in the past, that the hard-coded master key has been used for the AUC. So in this scenario, there was not used HSM to protect the AUC database and all the secret keys of the SIM cards of the operator, but they used the software solution. However, the software solution included the hard-coded keys directly in the binaries. So if somebody invests some time, do some reverse engineering and analyze properly these kind of binaries, the consequence could be that if he managed to get access to the system, he can then easily decrypt the AUC database, and basically the operator could not change this easily. Okay, so it is quite obvious that it is quite critical to address this. And on the right, we see again scenario that still, even if the 5G improved the let's say interconnect security, or there was quite significant effort in this, because we have SEP, we have N32 interface, which should be something like secure tunnel between one mobile operator and the other, and at least provide some confidentiality and integrity protection. Still, the messages inside, which are received through this tunnel, need to be inspected, and there needs to be performed application level filtering, similar to the legacy SS7 diameter GTP signaling, and we need again to do this. So there exists GSMA FS36 document where we try to contribute and to define this kind of filtering, which helps and reduce the attack surface and protects the mobile operator from the interconnect attacks. Okay, now
Thanks,
I will
Martin.
give back the floor to Philip.
Yep, thanks a lot. And here it's a perfect transition to see that even if there was quite some deep investment from many different stakeholders, the vendors, the regulators, the operators, into making sure that there's improvement into 5G security, there still are some problems. What we definitely see is that not all the security investment have the same return on investment in terms of increased security. We do see positive aspects in the landscape, considering the security posture of the operators and the networks. We definitely see that there's a strong push toward more education and more compliance with security frameworks such as the ENISA 5G security control matrix, but also things such as NIST focus. And every single region and many different countries are coming up with their own superposition of regulations, guidelines, references to information security management systems, so that they come up with their own view of what's a rational way to defend the network. We also see that specification-driven security improvement are improving the security, such as the concealed identifiers, SUSHI, the resistance to bad networks. So there are some good improvement. There is also an understanding from the specification bodies that some protocols that were considered like a final security mechanism, such as IPsec, were not. And somewhere there had to be a better way to do, for example, encryption. And here what we definitely see is that it's going in the right direction. For example, adoption of mutual TLS, also called as MTLS, into the core network. But very often we see some kind of lack of maturity in the deployment, either in the product. We've seen like a certificate authority, hard-coded and shared certificates, which basically enabled any network function to impersonate any other network function, but also down to the security management. If you can't manage certificates, well, basically, you're not going to be able to do anything valuable, any real security into the network. We see also that there's a lot of uptake of open source and strongly with cloud-native technologies such as Kubernetes, Istio, etc., but also more dedicated telecom technologies such as Open RAN, ONAP. So that means that they can be hardened. The problem is that the vendors say, well, if you do modification to something else at the configuration, then we don't guarantee that the network is going to function under heavy load or with good performance. So the result is that sometimes we have now the capability to do the changes and to improve security, but we still have to go the long cycle through the vendor so that the vendor does the changes, validates with QA that it's okay, and that it's included into the next software release. With 5G, we still see typical 3 months to 6 months lag or inertia in terms of having a new release, and that's super long. When you consider that a vulnerability detected by like some of the internet gigantic corporation, they give a 3 months maximum fixing time. So that means that the whole internet may know about a vulnerability, maybe sometimes 3 months before we get the patch into a 5G core network. And that's definitely difficult for a lot of operators. That's absolutely not acceptable for a lot of regulators. And now regulators are starting to say, we understood, now we are going to start putting pressure onto the operator, but also onto the vendors, so that vendors come up with better cycles. As I said, we still see not so much complexity, but for example, in the RAN with Open RAN, but it's coming up. And it's coming up, especially in some cases where they wish to deploy slicing, and not only fixed slicing, but also dynamic slicing. And there's a big difference between a fixed way of doing things and a dynamic with orchestration. And it happened on virtualization, it happened on slicing, it happened on many domains in terms of container, also dynamic management. And as soon as you go dynamic, for example, when an RF goes peer-to-peer and is dynamic, then you see a lot more potential abuses that need to be tested. And to test that, you actually need to test it with software. It's getting harder and harder to test it only with humans. So an hybrid approach where humans can test the vulnerabilities that are very specific to a vendor, and then software that test against the standard is the right approach. Now, on the negative side, as I said, we still don't respect enough the rule of two, with memory unsafe language being used for daemons and application and services that are actually listening to the network or receiving signaling from the network. And very often, this is so deep into the stack that an SaaS, CAS, security assurance scheme can't really test for this. It's too specific to a vendor, and that gives a false sense of security, which is detrimental in the end. We still see capability to do signaling abuses, and hence the necessity to monitor the network at the signaling level, even on 5G. In terms of technology complexity, we've seen vulnerabilities straight up from misconfiguration down to, of course, vulnerable versions still being shipped by the vendor, and reluctance from the vendors to change their base image, sometimes just to integrate the hooks necessary for EDR products. Hopefully not products that crash when they are updated, as you've seen in the recent news these last weeks. We see also a big need in terms of crypto management and authentication management of these network functions, for example. And this boils down to the big next point, which is not all vendors are actually the same in terms of security. We see a big vendor risk management need and a supply chain risk management. And from some vendors who still have hard-coded and documented vulnerabilities, or basically some other people call that backdoors, down to just vulnerable software, what we see is actually, we see plenty of needs in terms of considering the vendors as a new attack surface. That means that vendors are not only the people who give you the software to run the 5G core network, they are definitely on the handset level, but they are definitely also on the cloud technology providers. And since we see that there's an arbitration between an arbitrage and a trade-off between the speed up in technology deployment with cloud technologies and the need for sovereignty and security assurance, we see that some operators' plan to go to the public cloud are actually getting forward. So that means that the vendors are not enough threat-centric. They don't focus enough on what could go wrong. They're still too much into what we call specification-driven development, where they code their security according to the specification from 3GPP. And that prevents any kind of speed up of technology adoption for security, which would prevent upcoming threats. And that's a big problem. Now, finally, if we look at the takeaways and the conclusion of this presentation, we see that still network compromise is very feasible from a lot of perspective. We've done recent red team engagement, so it's a bit like a penetration testing, but we are given very little information about the target network, and we basically have the goal to penetrate it externally. And so we did some even physically in Europe, in North America, in different regions of the world, in Asia, and where we were able in a few days to compromise the core network from externally from 5G physical site in the field. So that means that we have some kind of hybrid attack surface that can be attacked by many ways. Of course, we don't do some of the attacks that the like advanced persistent threat can do. For example, we don't attack the supply chain in order to compromise a given network, but that's some things that are being done right now. So that means that any kind of upstream that is providing you anything, network transport, software, computing power and cloud services, is an attack surface. And the fact that we're using now very open source technology means that we could defend against that if we had the capability to change this, considered the vendor sometimes blocks there. But all the attackers know exactly what kind of technology we are using. Only the deep technology of network function is something that is still proprietary, and their management interfaces, the OAM, the OASS for each network function is still proprietary. All the rest means basically that the attackers know about the weakness of these foundational technologies, which means that we really need to have a deep threat hunting, threat-centric defensive and deceptive security in order to catch early these attackers, because they have still a vested advantage. Really, compliance is really helping. So we see that there's a lot of things, but the consequence is that the operators that didn't invest in their security end up paying much more because they are pressured and then need to kind of show good faith. And it's always the same. There's many smaller operators who don't invest early in their security and end up having high costs. And finally, what we see is that edge computing and private 5G means that there's a lot of pressure from the enterprises to the operators to provide not only communication services, but security services. And they come also with their big set of security problems. So here, I'm going to jump maybe into basically the question. Pierre, I think you had some polls during the presentation. And thank you very much for your presence. And let's go into actually Q&A. And I think there were still some in the chat. Maybe we will answer.
Sure. So there has been, thank you very much, Martin and Philippe, for your presentation. There has been some questions. Both Philippe and Martin have answered to some of them. I see a couple that have not yet been discussed. A quick reminder for anyone, you have the email that on your screen. You can either request, I've looked at my inbox, it's packed. So I will send the slides. Just give me an hour or two after this. You will all receive a link to the replay by default. The slides are a little bit more touchy, so that's why I need to know who is asking to make sure. And so yeah, if you have any questions that you may not want to address publicly, do not hesitate to use that email address. And now back to the question. The first question is from Sambasiva. Maybe Philippe, you can take this one.
Yes, absolutely. So the question was, about the internal 5G core network traffic, saying that it can be encrypted. And yes, the technology that is usually used for that is mutual TLS or MTLS. So is it mandatory to encrypt? Sadly, no. And that's basically a recommendation from 3GPP, where you can perfectly deploy with HTTP2 and without MTLS. This is kind of outside the recommended way, because for HTTP2, the recommended way is to have HTTP2 by using by default MTLS. And when you deploy it without MTLS, it's called HTTP2C as clear text, and it's not recommended because fewer security. The problem we see is not only about the fact that MTLS may not be used. When it's used, sometimes it's using certificates. So basically the keys, the private keys to these MTLS communication are actually shared between all the network function. So what that means is that if I'm an attacker and I compromise one network function, then I can impersonate any other network function within the core network. And you see here, the big problem is not only having clear text communication. The problem is sometimes having MTLS but managed in a wrong way means that you have a false sense of security. And what we see is that false sense of security is actually more dangerous than knowing that something is insecure, because some people then do their security management, their security architecture, in a way that knows that there are some vulnerabilities, but protects the most desirable, the most important part of the network. And that's where we see that this false sense of security, sometimes by badly designed MTLS networks, is worse than actual lack of some security feature. Now, your question was also about all SBI interface should be encrypted. Yes, they should. What we see is that you were asking about some only few interface based on communication matrix. We don't see that. It's either it's HTTP2 clear text, no MTLS, or it's deployed but managed insecurely with insecure and non-changeable defaults, or it's managed securely and with good MTLS and with dynamic certificates. So that's the current answer, and it's right now both within the PLMN, so within the network, and also between networks. But for between networks, that's the roaming side, and there's still a huge debate on how to interconnect correctly between two networks. I hope, Sambasio, I hope I replied correctly to your question. Now, Pierre, there's also other question. Do we have time?
We have 2 minutes to take Alexandro's question. Alejandro was asking, what is the status of the recommendation to use EAP AKA?
Yeah, so on this, I don't know if Martin, if you want to jump in there, but there's definitely it would require definitely more time than 2 minutes to get in there. So yes, I propose that we either do a call or basically are doing some email answers there. There's also a question about packet trace, etc. So now all this will answer, but there's many tools that enable to go for distributed capture and for information, for getting basically tracing the communication within a 5G core. And especially now there are things such as OpenTrace and Jaeger within basically a Kubernetes infrastructure that enable to cope with these MTLS deployments. And these are standard technologies, so very interesting. Once again, definitely let's follow up that by email, because we are at the end and don't have much time to go into the details there.
Okay, great. So Laurent and Alejandro, I will get back to you and try to give you some more information. Thank you very much to all that have been looking at that webinar, and to the one that will be looking in the next few hours and days. Thank you, Christina. Thank you to everyone, Philippe, Martin, and we'll be back soon. The next webinar is on the 9th of October with a great partner, and we'll look into conformity, compliance, regulations, NIS2, DORA, the 5G toolbox from ENISA. So, very exciting topics to discuss with the former CISO of one of the largest European mobile network operators. We are communicating the day after tomorrow, so hopefully you will be interested, or your team will be interested. But again,
thanks a lot, and definitely don't hesitate to reach out to the email contact@pwtech.com. We've had some past requests about new content, some things we could not talk about during this webinar, to do a deeper webinar. So, for example, on SCP security, etc. So don't hesitate to ask direct questions there, and we'll come up with this content. Thank you very much.
Thank you, everyone. Bye-bye. Have a nice day.
Bye.